I'll go ahead and record. Okay. All right. So today I'm calling data day one and day two because we're kind of mixing a bunch of data standards together. So I figured I would give you two opposite memes here. The first one says, I just love data. Data is my favorite. Right. A little elf there. And then I don't know who this guy is, but this is kind of how a lot of people feel about data. I was told that do it fun. I'd be doing fun data science thing. You're like, no. Okay. So, I'm going to send out weekly grade updates today. I'm about halfway done with that. A lot of graded stuff got turned in this weekend. So I've been working a good bit last night and this morning on that. Still going to work more on that, and I'll get finished today. I have also noticed that there's like this combination of two errors that some people are making. One is the people who follow my videos and write the things down but don't understand what they're doing. That's no good. What is also no good is if you are turning in the work and don't understand what you're doing and not watching over the video that I provided to go over it. And that's how we make more teacher assistants time in this course. Okay. So you really got to kind of understand that you've got to attempt it, then use my video to check your work. Okay. Target time Monday to Thursday this week, 12 to 12:45 as normal. If you have specific things to ask, all right. Then I'm getting the geometry quiz 2 in today. I'm in process of that. Make sure you see there are basically 5 assessments in so far for this quarter. There were 2 weeks of liftoff for Legends of Learning. We had a weekly review 9 last week, and then all the days of practice in Nearpod. So keep track of your grades. We've got about 4 weeks till grades cut off. Actually, it is 4 weeks. Okay. All right. So let's get switched over here. If you are not yet on Nearpod, you need to get there. Okay. So that's where we are right now. I'll repost the link and we'll be ready to get going unless anyone's got any questions. So if you'll see here, there's this big like conglomeration of standards we got left here. Okay. And I'm not going to be able to hope to get us all the way through all of this in the depth I would like to, but I'm at least going to give you a decent shot at each of these things. Okay. So what I'm going to be looking at today is just some parts of each one of these. So I'm not going to necessarily highlight all of them there, but just know that I am thinking through carefully how we're going through this. All right. So today, the goals are choosing and interpreting appropriate data displays for showing categorical and numerical data. So first, we got to make sure we know what those terms mean. Okay. So if you're not logged in yet, I'm not sure what you think you're doing, but there's points associated with doing this while I'm teaching. Okay. So you should have it right because you're doing it while I'm teaching. All right. So this first one says Priya wants to know if basketball players on a men's team and women's team have had prior or previous experience in international competitions. She gathered data on the number of times the players were on a team before 2016. Okay. So the first question, and I want you writing these down as we're going. Okay. Did she collect categorical or numerical data? So go ahead and put your answer right there. Okay. Is that categorical or numerical data? Is it categorical or numerical data? Okay. So you should be writing down either numerical or categorical, right? Not rocket science. Okay. So this would be numerical data. Okay. So it is a quantity, an amount, right? It's a number. Okay. Now, what we're going to do here is next, we're going to organize the information on the two basketball teams into these tables. What this means when it says frequency, the amount of times it happens, okay, is that each time you see that number there, okay, then you put a tally mark here. Okay, so watch what I'm doing here. So on the men's one right here, see there's a 3. So I'm going to put a 3, put a tally right there. Notice I saw the 3, so I put a tally there. Here I've got a 0, so I'm going to mark out a 0, put a tally. Mark out a 0, put a tally. mark out a 0, put a tally, mark out a 0, put a tally, then a 1. Okay, see what I'm doing here? And then the women's one goes over here. Okay, give you a few seconds to do that, and then we'll check over it. Okay, so go ahead and do it. I'm going to go ahead and do mine. And then when you're done, check back with mine, see if you got the same thing. Okay. And when you do a 5th tally, you do a cross one. 7, 8, 10. Okay, then the women's team. Okay. So here is my results. Okay, so I've got in the 0 for the men's, I got 10. I got one person who's been in 1, 3, one person who's been in 3. The women's, we got 3 people who've been in 0, 4 who've been in 1, 2 who've been in 2, and 3 who've been in 3. Okay. Any questions on how to kind of do the little tally table thing? That's all you got to do. Okay. Give you a few seconds, make yours look like mine. You're just recording all the tallies. So there's still about 10 of you in here who are not currently doing the Nearpod. And understand that I don't actually do attendance by whether you sign in on Zoom or not. Okay, your attendance basically is whether or not you did the work. Okay, you're not fooling me. Okay, so everybody make sure you got that chart done. Okay. All right, now, next thing is all right, so now we've got to actually use the information from the last slide. Okay, so I'm gonna flip back and forth here. So all right, we got a dot plot. So we're gonna put a dot for each one of these, okay, that we had on the previous slide. Okay, so a dot for each one on the previous slide. Okay, so we got let's see, men's, we have, all right, let me look at my results here. Oh, did I somehow delete mine? What in the world? I think it was 10, 1, 1. Yeah, it was. Okay, so right here, you need, all right, so we need to put 10 dots. So these are dot plots. So we're going to do it like this. So like 1, 2, 3. This one's going to be kind of weird because we got a bunch of dots above the 1. So I'm just going to put them like this. 6, 7, 8, 9. Oh, wait, those were supposed to be at 0, weren't they, Chloe? Yeah, they were. My bad. Those are all supposed to be at 0. Apologies. Okay. There's 5, 6, 7, 8, 9, 10. This would be the exact same thing as the ones with the little X's, right? Those kind. So we're just putting like this. Okay. Does that look right? I think it does. All right. All right, Lorraine, what's your question?
How do you know how many dots you have to put above the number?
Because on that, this is the same question from the last one. The one we were doing right here. See, we're just doing this one again. Okay.
Okay, but with dots.
Yeah, so we're using the number from here. And so because you're just kind of having to follow, like, unless you just, I don't know, it's kind of hard for you to be able to see that at the same time. I know, so that's okay. All right, so let's see. The second one we had, what was it? 3 zeros, 4, is it 3 zeros, 4 ones? I'm just checking this person's to make sure it's right. 2 twos and 3 threes. Is that right? Okay. All right, so let's go to the next one. And then, all right. So apparently he likes to delete mine if I go off of the slide. Okay, so it was what, 3 zeros? Okay. Chloe, what was the next one? What was the ones? Can somebody tell me what the ones was? Because if I go back, it's going to delete it. I think it was 4 ones. All right. Who else remembers? Surely somebody's remember what theirs was. I think it was 4 ones, 2 twos, and 3 threes. Yeah, that looks okay. So, all right. So I think it was this. And the deal is, it's only because I'm using this particular app, but that I can't really go back without erasing mine. Okay, so there's that, right? And then this one was 10 of these. I remember this one. All right, like that, and then like that. Okay. All right. So make yours look like that. Then it is an essential part of what we're doing on this particular thing that we write out these answers. Okay. So I would just say put it in a little typing box here, make your text smaller. Okay. All right. So we're looking at here, what do we see about the competition experience of the men's basketball players versus the women's basketball players? So go ahead and put an answer there. And then in a few seconds, I'm going to kind of go over that. And then why would the number 5 says why a dot plot is an appropriate representation for her data. Why does that work? Why is that a good idea? What?
First one, it was 4 for the women.
It was 0 on the. There were 3 zeros, and then 4 ones. Okay. So let's see what we got here. So what we're looking for, on the women's one and the men's one there is not, this is not a numerical answer here. Okay. What we're looking at, Oscar, will you go get the dog, please? Go put him up. Sorry, our dog is barking. It's annoying. Yeah. Okay. So somebody said they're competitive or not competitive. That's not it. Okay. And it's not about how much they score either. Okay. What this was about is their experience in competitions around the world. Okay. So what we would be looking at here is this. When I look at this, this shows me that this men's team is not very experienced, right? Because they only have 2 players who played in international competitions before. So I'm going to write my answer for this one. And yours doesn't have to be exactly the same as mine, but like some of y'all were not on track here. Okay, so let's take a look. All right, so what I'm saying here is the men's team is not very experienced since only 2 have been in international competition. Okay. So that's the first one there. Okay, the men's team is not very experienced. Only 2 have been in international competition. And it just cut off my answer there. There we go. Okay. Then I'm going to say the next one. Let's see if I move this now. Okay, the next one I'm going to say the women's team is experienced overall since 9 out of 12 players, 75%, have been in international competitions before, right? Okay, then that leaves us with the third question here. Okay, and you can leave it where it's kind of funky looking like this because I can still read over it. Then the third part here is asking us, well, hold on. Why is a dot plot an appropriate representation for the data? Well, compared to when it was just laid out on the table, I would say this is just kind of a common sense one. Right? You can see clearly how many people have a certain amount of experience. Okay, just type those in. I'm just trying to teach you how to explain these things. Okay, any questions on kind of what I was getting there and why that conclusion made sense? Okay, might need a little more time. So yeah, some of y'all need to finish up your answer here. Okay, all right, moving on in about 10 seconds. Okay. Okay, so this says Kieran wants to know which three summer sports are the most popular in his class. Okay. And so we got this list of them. All right. And so the first thing it asks is this categorical or numerical data? And I would hope that you could recognize that these are not numbers, right? They're category type things. So just put a C right there. Okay. Then organize the responses in a table to help him find which summer sports are most popular in his class. So I see swimming here. So you could just put like SWB, okay? All right. So I'm gonna go ahead and mark that one out. Put one tally for swimming. We got gymnastics. So I'm gonna put just GY there. All right. Track and field, TEF. So I'm just putting one right there. Volleyball. Okay. Now we got two more swimming ones. So now I got three swimming. All right, give you a second to catch up with me here. Maybe get ahead a little bit. Okay, because all we doing here is this. We're just going through and doing the table, collecting our data. Now we could also do like this. I'm gonna go through, I'm gonna find the other swimming. So I need to put two more swimming. So I should end up with looks like five swimming. Okay, gymnastics, I see one, two, three, four more. So I've got five gymnastics. Okay. I'm trying to be smart this time and writing them down as I'm going. Um, then track and field. That's what our family does right now. One, two, three more, four, five, six more. So we're gonna have seven total. Okay. So track and field is seven. All right. Now volleyball, we got one, two, three more. So four total. Okay. Yeah, I know there's a couple more sports. So diving, I see, and that's kind of weird because that's normally with swimming and diving. So I got one, two, three diving. All right. Then we got basketball. All right. BB is going to be 2. All right. Then we have rowing. We got 2 people who like rowing. And I row at the gym sometimes, but it's not fun. It's so hard. Yeah. Chloe says it's boring and she doesn't like it, which I don't blame her. All right. You just sit down and pull a string. Yep, that's right. Okay, so that's my chart. Okay, give you a few seconds to catch up on your chart. Again, there's not something super fancy about this. You just got to pay attention to the detail, right? As long as you pay attention to the detail, you should not get one of these wrong. Okay. Now, the bigger question here, and what we're working on is like, why is, why is this a good choice of data display? And, or the one we're about to do. And then, what can you learn or interpret from that? Okay. It's kind of what we're working on to begin with. Okay. Give you a few more seconds to finish up. And if you're following it, it shouldn't take you that long. Now, I see some of you wrote the numbers. I prefer to see the tally marks. I won't mark off if you do have numbers, but the idea is that you tally them here and then you display the data on another chart. Okay, that's how that's supposed to work. All right. Okay, moving on in 5, 4, 3, 2, and 1. Okay, so now we need to represent the information as in the table as a bar graph. Okay, so what we're going to do here is we're going to put so underneath it, you just put some label for swimming, however you want to do that. So like this, I'm going to put swimming right here. And then above swimming, I'm going to go up to 5, like that, and then somewhat shaded in anyway, right? Like that. Okay. So we got 1, 2, 3. We have 7 categories. So you got to kind of make sure they're small enough to fit. All right. Then we have gymnastics. So G is going to be 5 also. So we're going to go up to here. All right. So bar graph like this is useful for categorical data. Okay. Where you're comparing categories. All right. Track and field is going to be 7. All right. They obviously did not do the survey in South Carolina because football is not like what in the world. All right. And then 4 right here for volleyball. Okay. Then diving, which strangely is not with swimming, is going to be at 3. Okay. Then basketball is 2. Like this. All right. And then soccer was also 2. Okay. Now, all right. So that is our 7 categories. All right. So how can we use the bar graph to find how many classmates Kieran surveyed? Okay. And I'm pretty sure I've done a bunch of these this year where we've done this kind of thing. So here we're just writing our explanation. Chloe, I actually didn't come up with that. And that's not how you spell Kieran's name anyway. All right. So the answer to this is, how are you going to find how many total classmates he surveyed? Okay. So go ahead and write that in. All right. And then we'll answer the other two. Give you a few seconds to catch up. Not all the slides will take this long. Right. This person is on the right track right here. They finish that up. Yeah. You'll add all the plots up to do something. That's the right sort of answer we should be looking for here, right? Okay, so your answer for this for A right here should be something like this. You add up the totals from all the bars to see how many students were surveyed. Right? That's it. That's how you do it. Okay, because we've done these this year a good bit to find percentages and stuff, right? Okay, Lorraine, just make sure you come back and go on the student pace one and do the other slides. Okay. Now looking at the bar graph, his question about the 3 top summer sports in his class. So right here, let's write down. So we'll put the 3 top ones. Okay, 3 top sports are. So write down the 3 top ones there. All right, so the 3 top ones. So the answer for 4B, you should have track and field. We should have swimming. And we should have gymnastics. Then make at least one other observation based on your bar graph about the classmates' preferred summer sports. I already made one, clearly not in South Carolina because no one said football, right? So you could say anything like soccer wasn't popular. That would work. You could say you put swimming and diving together, that's even more for that sport, right? Soccer wasn't popular. That was my observation. You should be able to make something different than me because there's about 20 different things you can notice. Okay, could a dot plot be used to represent Kieran's data? Anybody got a thought on that they're willing to say out loud? Anybody willing to answer 5 out loud? Could a dot plot be used to represent Kieran's data? This is actually a pretty important question for this standard. Could you use a dot plot here? Okay, the answer is no, because you got the wrong kind of data. Okay, because we have categories. Okay, dot plot. Well, hold on. Dot plot for. Oh, wait. Yes, we could. Sorry, because we could put the sport and then put the number. Yeah. I'm sorry. Yes, because you could put the sport, and then the number of dots above it. Okay, so the sport could still be at the bottom, and the dots for per person. Okay, apologies there. I was thinking about it the wrong way. Okay, so both of those could work here. All right, now there's a different type of data display we're going to get to where it would not work on this. Okay, so you could use a bar graph or a dot plot kind of thing here. You couldn't use a histogram. I'll get to histograms in a bit. Okay. All right. Any questions on that? Okay. Now, think after this, there's not nearly as many we have to kind of do a lot of together. Okay. All right, I'll move on in about 10 seconds. Okay, so I'm going to kind of talk you through some things here, right? Just some terms. Okay, so here are some important terms just when you're getting these data questions to make sure you understand. So when we analyze data, we're often interested in the distribution, which is information that shows all the data values and how often they occur. Okay, so like this one occurs a lot, this one doesn't occur a lot. Okay, so how they're distributed means there's some here, some here, some here, right? Okay. Um, the term frequency in the data set tells you how many times the data occurs. So in this case right here, there are 3 dogs that weigh 7 kilograms. So 3 is the frequency for 7 kilograms. So if you'll notice right here, each one of these dots refers to a dog. Okay. This is one dog that weighs 6 kilograms. This is one dog that weighs, looks like 32 kilograms. Okay. So dot plot and the frequency table both show the distribution of the data, okay, because each one of these refers to a dog. So frequency means how many of them there are. Okay, a dot plot uses a horizontal number line, and we show the frequency of the value by the number of dots drawn above that value. So the 2 dots above 35 says there are 2 dogs that weigh 35. Okay. Now, here is like in a table right here. So categorical data. Yeah, so a categorical data is usually going to be a bar graph. So I think my original answer probably is the one that made sense because you had to put the number on the bottom of the dot plot. So I actually think I may have stated that incorrectly there. The deal is you could put basically what looks like a dot plot and put just X's above them. But I think the idea that they're going for here is that the technical little dot plot term they're using has a number under the bottom. Okay. Whereas on the bar graph here, the numbers are on the vertical, the Y axis. So, all right. So one thing I wanted you to notice on this one, I think it's important in moving forward. So you notice here that on this particular data display, the intervals, meaning what they're counting by, they're counting by 3. Okay. So that means there's 9 pugs and beagles and 12 German shepherds. So if it's like that, and there was one like right here, you'd have to say, oh, that's 10, that's 11, that's 12. Okay. So just make sure you notice what they're counting by as you're counting up on a data display. Okay. All right. So on this one, all right, I'm going to kind of go into a few other things that I want you to be able to do with these in the next couple of days. So it says 25 sixth graders answer the question, how many hours do you generally spend on homework each week? Okay. So it first says, why is this a statistical question? All right. Why is this a statistical question? We already done this standard earlier. So statistical question means one in which the answers can vary. So there's not like one definite answer. The answers that people give could depend, right? Okay, now this dot plot shows the number of hours per week these 25 students reported spending on homework. Okay, now the first one here I put is what percentage of the students reported spending 1 hour on homework each week? Okay, so remember percent. So I'm going to work in some percents this week too and reviewing that. So we got percent, all right, is a ratio out of 100. So the way we're going to start this problem is we're looking for the people who spent 1 hour. Okay, so write the ratio down like this out of the total people. Okay, now in this case, we count how many little dots there are. 1, 2, 3, 4, 5. So that means 5 people spent 1 hour on homework. Okay, so notice where I got that from. Okay, we're looking for the percent of people that spent 1 hour on homework. So we start with writing the ratio of people who spent 1 hour. There were 5 out of, notice right here, it says 25 6th grade students. Okay, any questions about where I got that ratio from? Now, we want to make this a percent. Percents are ratios out of 100. Now we should be able to solve this problem. So you got to figure out this 25 times something equals 100. Okay, so then you do 25 times 4 equals 100. And then what you do on the bottom, you do on the top. Okay, so 5 times 4 is 20. Therefore, the answer for A is 20%. Okay, 20%. Okay, questions on that? It's just reviewing stuff we've done before, and we're just doing it in a different sort of question. Okay. All right. I do want you to notice here, there's another part of our standards here that are talking about the pattern of distribution of the data. Here, there's not really a good pattern. It's all spread out. All right. So there's a lot of variation in the data. Okay. Now, the second part here, B, the percentage of students that reported spending 4 or fewer hours. Okay. So that's all of these, right? 4 or fewer means include the 4. Okay. So we got 4 less than, or I'm going to put less than or equal to 4 over the total. Okay. That's a less than or equal to sign there. So now we're counting how many are less than or equal to 4. Okay. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 out of 25. Now, if I want to check, make sure I'm right, I can count the ones that I left off. 1, 2, 3, 4, 5, 6, 7, 8. 17 plus 8 is 25, so I'm good. Okay, now I need to make this a percent also. All right, so this is going to be times 4 times 4. So 17 times 4, you might need to do that on the side if you're doing this on your practice problems, equals 68. Therefore, that means 68% of students spent 4 or fewer hours on homework. Okay. Give you a few seconds to finish those two up. Just trying to kind of make sure we go through all the skills I want us to work on the next couple of days. Okay. Any questions on this skill? We've done this one quite a bit this year. Okay, moving on in 10 seconds. Okay. All right, now center and spread. So let's kind of go over a couple more definitions here. So one way to describe sets of data is by using the center or the spread of the data. Okay. So measures of center would be mean, median, and mode. Okay. So when we look at this, these right here, the overall center of this is less than the overall center of that. We can say that. Okay. So the center of the cat weights is between 4 and 5 kilograms, somewhere in there. And the dogs was between 7 and 8, somewhere. Okay. If you average them out, the center of it is going to be somewhere in there. Now, the spread here, you would say that the dogs have more spread. They're more spread out, whereas there's more of a cluster in the middle for the cat weights. Okay. So that's one way you could talk about the data. Okay. All right. Now, so we often would say, continue the same question, that values near the center of a distribution are typical for that group. So what that means is you could say, all right, what is a typical weight for cats according to this data display? You would say between 4 and 5 kilograms is a typical weight. So what is near the center of the data set is what is typical. See it? So what's near the center of the data set is what is typical. See? So for the dogs, what is typical is somewhere right in here, right? So between 7 and 8 kilograms is typical for the dog. All right. The dog weights are more spread out than cat weights. The difference between the heaviest and lightest cat, 3 and 7. There's only a range. If you subtract the heaviest and lightest, is 4. But for the dogs, it's between 11 and 5. So that's a range of 6. Okay. So the one with the bigger spread, meaning dogs in this case, has greater variability. So it depends from dog to dog more than it does from cat to cat. Okay. So in general, we could say cats are more similar in their weights than dogs, which differ more. They're more variability. They're more spread out, more different. Okay. Any questions on those? I just kind of wanted to go through some of those terms. Okay. This is kind of the stuff we have to do here on the standard. Okay. Okay. So we got 2 more slides, then the conclusion. All right. So the next one. All right. 25 6th grade students had to estimate how many hours a week they spent talking on the phone. This data plot represents their reported numbers of phone usage. Okay. So the first part says how many of the students reported not talking on the phone during the week. Okay. So we count them up here. So you explain how you know. And you just put something like count dots. That works. Count dots. Okay. Now, how many reported not talking on the phone during the week? I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 students reported not talking on the phone during the week. So what percentage of the students didn't talk on the phone during the week? So the percent means we write the amount that didn't talk on the phone during the week, 10 out of the total, which they told us was 25. Then you make that a percent. Percents out of 100. So I'm going to have several of those this week. Times 4. Then do the same on the top you did on the bottom. And you have 40 over 100 or 40%. Okay. Questions on that one? All right. The largest number of hours a student spent talking on the phone per week was 3, right? So 3 was the largest number of hours anybody spent talking on the phone. Okay, so notice here, the last question says, what percentage of the group reported talking on the phone for 3 hours? Well, don't get confused on this because it was 3 dots because that was 3 people, right? So 3 people talked for 3 hours out of 25. And that equals, and we got to do times 4 again. Do the same on the top we did on the bottom. And that's going to be 12 over 100 or 12%. Okay. All right. Any questions on that? Get caught up on that one. And then we got one more slide to do. And then I'm going to kind of give you concluding thoughts. Just be aware that the way I check over these Nearpods is I look over every slide and I tally up which ones you've not done correctly. And then I take off a certain number of points based on how many you didn't have done correctly. Okay. Which I'm sure y'all probably basically figured that out, but I figured I would just restate it for those of you who didn't know that. Okay. All right. So one more slide here. How many hours would you say these students typically spend talking on the phone. Okay, so if we looked at that, it was what was our numbers? Between what, 0 to 2 hours, right? All right, so me personally, I would just say 0 to 2 hours. Okay, and then how many minutes per day would that be? And that is that hours per week. Okay, so that would be, that's a little bit confusing. So that would be 0 to 2 hours and then minutes per day. I don't necessarily want to take the time on that because we're kind of running out of time. You would take the 2 hours and divide it by 7 days. Okay, and unless you want to do just school days. All right, how would you describe the spread of the data? All right, not very spread. Not very spread. All right. So I would say not a big range. Okay. There's not a big range. All right. It's not very spread out. It's just between 0 and 2. Yes, Lori, I certainly will. Okay. Now let me go to the conclusion. If you got some slides you need to finish up on, either one, hang around and I'll go back to them so you can do them now. Or if you got several you missed, then you might want to go on the student pacement. Okay, so here's what we got going on. Today and tomorrow, we do have 2 days of short practice. And then there is a weekly review 10 this week that's a major grade that you got to make sure you find time to get done this week. Okay. All right. So Lorraine wants slide 10. All right. Anybody else need another slide? Let me know. All right. 1 second, Lorraine. Stop.